Hello students! So this video here is about the intercept form of quadratic functions, and depending on where you're looking or what type of things you're looking at, they may refer to this form as a factored form. And again, they may refer to it as a factored form because, as you'll see in just a minute, again, it's a factored form. But again, it's called intercept form. Let's look at how this intercept form looks, or this factored form looks. Alright, so the intercept form for quadratic functions looks like this. And again, as you see it here, they've got the variables in it besides x and y are a, p, and q. And so, again, when we're going to take a little look at what each of these variables or each of those little components indicates when we're talking about this intercept form. Again, the p and the q, those parts will actually wind up determining the intercept, and by intercept, the specific type of intercept that I'm talking about is an x-intercept. So the p and the q, those parts of this formula or of this intercept form are going to, or in other words, it's an easy way for you to determine what the x-intercepts are. So this form here easily reveals your x-intercepts, which are, again, p and q. So again, folks, p and q are your x-intercepts in this form, and we'll talk about what the a does momentarily in a little bit. And so, guys, p and q, the way you would identify them in this form, or the way that you would specifically identify exactly what the value of p is or what the value of q was, if you actually had numbers in this intercept form, is sort of similar to the way that you would identify the h in the vertex form. So yesterday we talked about the vertex form in another video, and again, in that vertex form you had something that looked sort of similar to what you're seeing here, where you see x minus p, but again in parentheses, and in that vertex form it looks sort of similar to that, where you saw x minus h inside the parentheses, right? So again, folks, the same way that we had to sort of look at that h, and the same way that we said that minus doesn't really mean that it has to be negative, or that it has to be a minus sign there. What that minus sign means for this p and q is that you have to take the opposite sign. You've got to use the opposite sign of whatever you see in the equation, of whatever you see in this intercept form for p and q. You've got to use the opposite sign when you're identifying the value of p and the value of q. And of course, guys, I'm going to show you an example. Alright, so again, folks, your x-intercepts are p and q, and the values for those x-intercepts comes from using the opposite sign as what you see in the equation. Really briefly, let's talk about what the a value helps us to determine, or at least we're going to talk about one thing that the a value helps us to determine. We haven't quite gotten to the other part of what that a value helps us to determine. But guys, that same a value that was in the standard form for quadratics, that was also in the vertex form for quadratics, is the same a value that is in this form for quadratics, the intercept form. So it's not that much of a stretch for you to be able to tell me that that a is going to help to determine whether or not your parabola is going to open up whether it's going to be a U shape that opens upward, meaning that it's going to have a minimum or a point, a relative minimum, or a point at the bottom of that parabola, or the A value is going to be negative, which means that the parabola is going to open down. And if it opens down, then there's going to be a minimum. Sorry, if it opens down, there's going to be a maximum. But again, so if the A value is positive, it'll open up and there'll be a minimum. But if the A value is negative, the parabola will open down and there will be a relative maximum. If A is negative, there will be a relative maximum. If A is positive, there will be a relative minimum. So again, folks, that's what these three values will determine in the intercept form for a quadratic function. Again, we've got the P, the Q, and the A. Your P and your Q are your x-intercepts, and the A value will determine whether or not that graph opens up, and it'll do that if the A value is positive, which means there'll be a relative minimum. That lowest point at the lowest point of the graph, relative minimum. And also if the A value is negative, that means that the graph will open down and there will be a relative maximum. Alright, so next we're going to look at an example, and in this example I'm also going to show you how I want you to show your work for the Delta Math assignment. That's a part of this assignment. Again, you're using this video first off to help you complete the discussion board. I'm talking to my students that are enrolled in my class right now. You're using this video to help you answer discussion questions that are attached to discussion board for this assignment, and you're also going to complete the Delta Math assignment, and there is a Khan Academy portion for it too, but again, the part that I want you to show your work on is the Delta Math assignment, and I'm getting ready to show you an example here, and in that example I'll be showing you exactly how I want you to show your work, and also I'll also be kind of doing a little bit more about what exactly we can determine using this intercept form, because we can also use these x-intercepts, the P and the Q. We can use those to help determine what the x value of the vertex is. So again, we're going to look at that example here. All right, so just real quick, we're going to look at a quick example here. So if it says state the x-intercepts of y equals negative x plus 8 times x minus 3. And again, this should be a fairly simple example here. But again, with that, you should be able to look at this form and you should know exactly which numbers we're looking at as far as the P and the Q are concerned. We're looking at this 8 and we're looking at this 3. However, remember folks, we said that for the values of these x-intercepts, when you're trying to determine that, they come from those values, they come from using the opposite sign of whatever you see in the equation. So again, you know that we're using the 8 and the 3, but pay attention to what signs that the 8 and the 3 have right now, because when we're identifying the P and the Q, of course guys, the P is going to come from using the opposite sign of 8. And again, in the equation it says positive 8. So one of the x-intercepts is going to be the ordered pair of negative 8, 0. And the other x-intercept is going to be the ordered pair of positive 3, 0. Because again, if we use the opposite signs there, we do get what P and Q are as the x-intercepts. And again, those are the x-intercepts. So again, negative 8 and positive 3. Now, if you were asked to determine whether or not the graph opens up or opens down, in other words, if you ask to determine whether or not there's a minimum or whether or not there's a maximum, you should be able to determine that. Here the A value is a, what, -1? The A value is -1, so since the A value is a negative number, that means that the graph is going to open down and there is going to be a maximum. Okay? So the A value is negative here, and again, it's understood that that's a -1, even though I'm about to erase that. It's understood that that's a -1 right there on the outside, and so because the A value is negative, there's going to be a relative maximum. And again, you can see, again, you should remember from our previous lessons what a relative maximum is and how that looks. So the vertex will be a relative maximum for this particular equation. Again, folks, that was just a quick little example. Next, we're going to look at what it looks like when you're trying to determine what the x-intercepts are from looking at a graph, and also what it looks like if you have to determine what or at least what certain parts of the equations of what the equation is going to be in the intercept form by looking at a graph. And again, for those of you, for my students who are enrolled in my class, again, you've got a Delta Math assignment that asks you to determine which equation matches the graph shown below. And again, for this particular assignment, again, folks, first you need to be able to identify exactly what the x-intercepts are based on looking at the graph, and then you need to know how that's going to be written in the equation. And then there's other things that I want you, my students enrolled in my classes, that I want you to show me as part of your work for this Delta Math assignment, and which I'm about to show you right now with an example. So guys, in this particular example here that I'm showing you, again, I'm gonna break it down step by step, things that I want you to do or the things that you'll have to do in order to identify first off the right answer, and then also the steps that I want you to show me after you've identified, of course, the correct answer. So the first thing you're going to need to do, and again, I'm referring to this Delta Math assignment here. The first thing you're going to need to do in order to be able to select the equation that best matches the graph is, again, first you're going to have to look here and you're going to have to identify what exactly those x-intercepts are based on the graph that you're looking at here. And you do need to look at this parabola. You need to look at whether or not the parabola is opening up or whether the parabola is opening down. And you need to actually state whether or not, or pretty much you need to know whether or not there's going to be whether or not there is a minimum or maximum there. And based on that, you need to be able to tell me whether or not the A value is going to be positive or negative, right? So yeah. All right, so let's do this. So I've decided to give you multiple choice, just like that problem on Delta Math that I'm asking you to do, my students enrolled for me at our school. And so again, if you were going to select the equation that best matches, or that matches this graph the best, the first thing you would need to do, and the first thing I'm asking you to do, and so if you'll notice this little orange asterisk, everywhere I've got an orange asterisk, my students who are enrolled under my class at our school, everywhere you see this orange asterisk, that's something that I need for you to show, something that I need for you to do when you're showing your work for this. I need for you to identify the x-intercepts and state if A is positive or negative, okay? And so again, that's the first thing that I want you to show when you're doing this particular problem set in Delta Math. Okay, so let's do that there. All right. So when you're showing that, you should be able to tell, looking here, you should be able to tell what the x-intercepts are by looking at the graph. Okay, if you look right there, that's clearly -3, right? That's the x-intercept. Okay, so the x-intercepts, you can tell me that there very easily, I'm sure. Oopsie. Try that again. Let's move you out the way. There we go. That's better. X-intercepts are -3, and what's the other one? 2. Look at there. X-intercepts are -3 and 2. That is our P and our Q, right? So our x-intercepts are -3 and 2. That's our P and that's our Q, clearly, right? P and Q. Or it really doesn't matter what order you put them in, which one you say is P and which one you say is Q, because they're gonna wind up being technically the same answer, even if the order of the multiplication is switched using the commutative property. All right, let's see here. All right, so that is your x-intercepts. You should be able to tell whether or not the A is a positive or negative number based solely on whether or not there's a maximum or whether or not there's a minimum. Again, you should at this point know that a maximum has a relative maximum is where the highest point is compared to all of the other points around that. And so this graph has a vertex that is a relative maximum. And so yeah. And so based on this graph having a vertex that's a relative maximum, the A value has to be negative. Okay. So again, as we said, a quadratic function will have a relative maximum if the value of A is negative, right? So again, your A value has to be negative because it's a relative maximum. So we've identified what the x-intercepts are, what the A has to be. Now, folks, remember that when you identify this P and Q, identifying that P and Q, folks, is going to be the opposite sign of what is in the equation. Remember that. Both P and Q for your x-intercepts are going to be the opposite sign of whatever is in the equation. All right. So again, when you're selecting the correct answer here, please remember, folks, that. So if we're using the opposite sign of what P and Q actually are, if we're using the opposite sign of -3 and 2, that means that we're going to have to choose one of those answer choices where one of the factors is x plus 3, because that would be using the opposite sign of the P, which is -3, right? So it would have to have x plus 3 as one of the factors, and it would have to have x minus 2 as one of the factors. So there's only two answer choices that have x plus 3 and x minus 2, right? X plus 3 and x minus 2. Then, guys, you use your process of elimination, because there's only one of those two possibilities where the A value is negative, right? There's only one possibility where your A value is negative from there, and so you make that choice based on that. All right, so the answer here has to be this one, right? Because again, it used the opposite sign for P and Q, right? It definitely has the opposite sign used for both P and Q. uses opposite sign for P and Q, and it has an A value that's negative, right? Yeah, y'all don't need to see me writing that. So again, folks, this equation is correct because, again, it uses opposite signs for the P and the Q for that part. And again, we had already identified the P and Q as -3 and +2, right? Those were our x-intercepts, -3 and +2. Okay? And again, here the A value is -1. So that's definitely a negative A value. And again, guys, that's the first part of what I need you to do. And so again, where you see the orange asterisk, I need you to do that and as part of showing your work. So identify the x-intercepts and state if A is a positive or negative number. Okay, if A is positive or negative, state that. Yeah. Alright, so yeah, it couldn't have been that one, and it couldn't have been that one, and it couldn't have been that one either. Alright. So, guys, on delta math, listen carefully. On delta math, this is where you'd be done with that problem. But guys, again, I want you to show more work just for what you see right here. I want you to show even more work. So keep watching. Don't hang up the phone, okay? Because I want you to show even more, okay? Because what I want you to do from here is I want you to identify what the vertex is using this particular intercept form. And see, why y'all didn't tell me that I forgot to write the y equals here for this one and the y equals for that. It's all good. Y'all know what I mean. Y'all know what I meant. Y'all forgot to tell me that I forgot to write the y equals. See, you know what? Anyway. So again, guys, as part of your work for each delta math assignment, and I've got a little orange asterisk here, so you can't be confused about it. Okay, so I want you to identify the x-intercept. State if it's got a positive A value or negative A value, and again, and that's going to help you identify the correct answer on delta math. From there, you're still not done with showing the work for me, the work that you need to submit as part of this assignment. From there, I need you to show your work for identifying the vertex, which I'm about to show you how to do. Okay? So, in showing our work for identifying the vertex from the intercept form, first off, guys, we know that we already have our intercept form, and we've already selected exactly what that form was in our answer choice. So again, we know that we already have that particular form, and that is y equals, that's y equals, I'm going to write that, negative x plus 3 times x minus 2. Alright, so we already have that. And again, we technically already have what P and Q are. Again, we already know exactly what P is and what Q is too. We already know that that P is -3. But again, I'm showing you again how you're going to use the intercept form to identify what the vertex is. So again, I'm showing you everything, all right? Not everything, but what you need to know. Oops, that is one sloppy looking arrow. What in the world is that? That's a little bit better. Only a little bit, but it's a little bit. Alright, so x is -3. Sorry, not X. Oh, y'all know I meant P. It's okay. It's been a long day. Y'all knew I meant P, didn't you? That's alright. So P is -3 and Q is 2. Because again, remember you got to use the opposite sign of what's in the equation. So again, we technically already have what P is and what Q was. So you're going to have to use that P and that Q to help you figure out what the vertex is. There's a particular formula that you've got to use to figure out what the vertex is. And so if you're going to do that, you need to know this formula here. So to figure out the vertex, or let me put it like this, to figure out the x value of the vertex. The x value of the vertex. We've got to use this particular formula here to figure out the x value of the vertex. The x value of the vertex, you're going to use that P and that Q. So again, to do that, it's almost like you taking the average of the P and the Q value. So you guys know how to find the average if you got two numbers, right? You add them. Add the numbers together, you take the sum of all the numbers and divide it by how many numbers there are. Yeah, alright, so we know how to find the average of things, right? Yeah, alright. So we do P plus Q and divide it by 2. Ooh, okay, try that again, redo. Okay, try it again, redo. We're gonna get it right. Okay, I give up. No, I don't. I really don't. Oh, that's a straight line. Oh, I like that. Hey, that was, it's good to have a ruler. Hey, yes, sir. Yes, sir. I tell you. All right. Enough of that. Now, P plus Q divided by 2. Again, it's like we've got to take the average of those two x-intercepts. And again, the reason why it's like we've got to take the average of those two x-intercepts is because that vertex is going to be like perfectly in the middle of those two x-intercepts. Like literally, the x value of that vertex is like perfectly centered in the middle of those two x-intercepts. You see what my mouse pointer is right now? I mean, that vertex is perfectly centered in the middle of that thing. And guys, trust me, it does not matter whether or not one or both of those x-intercepts is negative. You're still going to add them together and divide by 2. Even if one of them is negative or if both of them are negative, you should know how to add if some of the numbers are negative. If not, use a calculator. All right. Seriously. It's okay. That's why they got the technology. All right. Not trying to throw no shade. Just saying. There's some stuff that I can't do in my head. And I'm a math teacher. All right. So let's go ahead on and use that particular formula for finding this x value of the vertex. So again, we take our p value and we add it to our q value at the top here. So that's going to be -3 plus 2. Now guys, I'm writing it out like this, but I need you to know that there's a particular way that you are going to need to yeah, I'm sorry. I don't need for y'all to see me messing up trying to do a straight line, so we just going, yeah, okay. Awesome. Wonderful. Lovely to have a ruler. So again, I need for you guys to know exactly how to actually calculate this the right way, okay? Because if you just enter into a scientific calculator, -3 plus 2 divided by 2, if you try to put all of that in the calculator together, it's going to come out wrong, guys. I'm gonna go ahead and tell you. If you let me show you real quick. If this is what you put in your scientific calculator or graphing calculator, if this right here is what you enter in, -3 plus 2 divided by 2, you're gonna be wrong. Why? because your scientific calculator uses order of operations, just like your graphing calculator uses order of operations, PEMDAS. Your scientific calculator or graphing calculator is going to do the dividing first, meaning that it's going to say 2 divided by 2, and that gives you 1. So it's going to simplify the 2 divided by 2 to 1, and then it's going to do this adding, and it's going to say -3 plus 1. And guys, that is completely wrong. That is not what you want your calculator to do if you're using a calculator to do this. Alright, so I'm showing you how to do it whether you got a calculator or whether or not you are just doing it on paper and pencil, you know. Alright, anyway, let me erase this right here, because y'all don't need to see all that right there. Because y'all don't need to put that up there anyway. So, it's all good. Alright, so the way that you need to do this is you need to calculate the top of this first. And that's why I'm putting this in parentheses, right? Because again, in order of operations, we do what's in parentheses first. And so guys, you do what's at the top here first. And if you are using some type of calculator, scientific or graphing calculator, then you're gonna put that part in parentheses. -3 plus the 2 in parentheses, and then divide by 2. So your calculator can use the correct order of operations the way that you want it to actually find this average, okay? So we want to calculate the part at the top first, and again, you'd have to enter it into your calculator like this with the parentheses around that, and I'm getting ready to erase that because we don't need to see all of that. We don't need to see all of that. Alright, so again, if we calculate what's at the top here first, at the numerator, we got -3 plus 2, which gives us 1, but that's -1. And then we're still going to have to divide. And so that is, or either divide or you leave it as this fraction here. So the x value of this vertex, the x value of this vertex is -1/2. And again, guys, you can either leave it as a fraction like this. Again, like I said, folks, I'm a fraction person. I love fractions. A lot of you are just going to want to, by default, say -1 divided by 2, and you're going to want to just write it as 0.5. But it's just as easy for us to leave this as a fraction, -1/2. Alright, anyway, alright, that's the x value of the vertex. And so, now, guys, again, as part of showing your work, again, I'm reiterating this several times. So, again, you see what's in the asterisk. You got to do that. You see that orange asterisk? If you don't know what an asterisk is, ask somebody. If you don't know what the color orange is, I can't help you on that one. Alright, again, I'm talking to my students who are enrolled in my classes. Again, the exact way I want you to show your work for each of these Delta Math assignments. So again, you find that x value of the vertex. From there, guys, you are definitely going to need to take that x value of the vertex, and you're going to want to evaluate your function using that x value to find the y value of the vertex. And you should know what I mean when I say evaluate the function using that x value. Okay, you're going to plug in that x value, plug in the input, and you're going to find the output into you're going to plug in that input value into our equation, that y equals -x plus 3 times x minus 2, right? So again, we take that x value and we want to evaluate it for our y value. And so we find our y value by plugging in the x value. Find the y value of the vertex by plugging in the x value into that equation. By substituting, plugging in the x value that we just now got. So we're going to have to plug in that x value. Alright. So when we do that and we plug in that x value, again, folks, like we said, it doesn't matter exactly whether or not you write it in function notation or whether or not you write it in, you're going to plug in that particular x value that we just now got, right? And you're going to evaluate this particular equation. So everywhere, oops, give me a second. Everywhere where we have, where we've got that thing there, you're going to, everywhere where we have x, you're going to plug in that number, of course. Alright, so again, the particular equation that we've got right now is -3, was that x plus 3 and x minus 2, and with a negative sign out front. Alright, so we see here, guys, that again we want to plug in for each place where you see x. Again, I've written this in function notation, even though it's the same thing, y equals that, and again, I've just written it as f of x equals that, right? And so we want to evaluate this function, plug in that x value, evaluate it, right? And find the y value, the output. All right, so everywhere you see x, you're going to replace that with the -1/2, right? And so we do that, right? And so from here, let's go ahead on and do that. Calculate it. Oops. All right, try that again. Alrighty. So let's see. First off, that says negative. It's still negative right now. All right, -1/2 plus 3. That's going to give us 2.5. So, guys, whether or not you want to write this as a, whether or not you want to write your that -1/2 as a fraction or decimal, that's up to you. Again, you can write it as -0.5. Again, when you add this together, you wind up getting 2.5, which is the same thing as 5/2. Like I said, I'm a fraction guy. I love fractions, so hey, I ain't got no problem with doing fractions. 5/2, and again, this one here, when you say -1/2 minus 2, you wind up getting -2.5, which is -5/2. All right, so we've got to multiply these things here. You guys remember exactly how many things we can multiply at one time, right? But again, if you got a scientific calculator, you can just do all of this here. But again, let's see here. You multiply all three of these things, even though you're only multiplying 2 things at a time, technically. But again, if you put that all in your scientific calculator or graphing calculator, because I imagine most of you will, or into some type of calculator, even if it's on your phone, okay? And most phones do have a scientific version of the calculator. If you just flip it sideways and the screen flips on the calculator mode, anyway. Alright, so this winds up being positive, but I'm writing it like this first because I'm just multiplying these 2 things together first. Again, because I'm not using no calculator, and I gotta do it the way it's supposed to be done, where we multiply 2 things at a time, so hey, but anyway, when you multiply those 2 things together, that gives you -25/4, which is -6.25. And then again, if you take the opposite of that negative, so 2 negatives, two wrongs don't make a right, but two negatives do make a positive when you multiply them. Remember that. Alright, anyway, that's a positive there, and so this will wind up being positive 25 over 4. Again, folks, at the y value, you can put positive 6.25. But again, this would be the y value there. So we've got the x value was negative 1/2, and we just found the y value. And again, guys, if I'm asking you to identify the vertex, which I am as part of showing your work, all right? Because again, you need to follow the instructions that I'm giving you for this assignment, and it is going to clearly say that you need to show your work the way that it is shown in the video. All right, for my students who are enrolled in my class, come on. All right. So again, the vertex here, after we've identified exactly what that y value is, we know that the vertex is going to be written in a form of an ordered pair, x, y, right? So after we identify the x and the y value, then we can write out our vertex in the right form. Alright, so again, our vertex is negative 1/2 or negative 0.5, and the y value is 25 fourths or 6.25. Alright. Yeah. That's it as far as how I want you to show your work on the Delta Math assignment. Alright, so let's recap. When you're showing your work on the Delta Math, look at all of these orange asterisks right here in the video. Orange. Okay? You need to identify that and state that. Okay? You need to show your work for identifying the vertex form. Oh wait, did y'all really let me write from? That's okay. We'll get that straight. Just like it wasn't even there. Perfect. Alright, so again, we need to do all of the things that have asterisks there. Okay? As far as showing your work for this. Showing your work. Everything here that's got an asterisk. That's how I want you to show your work on when you do your Delta Math, each problem of the Delta Math assignment. And there's 6 of those Delta Math assignments. So, I mean, 6 of the problems that you need to do on Delta Math that I need for you to show your work. Alright, show everything like what I've got here on this video. Alright, next guys, next we are going to just talk briefly about how it is that you need to do your Khan Academy part of this assignment. And this part is not hard or anything like that. It's one little exercise with literally 4 problems. Yeah, it's not hard. With this Khan Academy exercise, again, it asks you to identify which form of the equation would be the best form for identifying a certain type of feature. And so when we talked about each of those 3 forms for quadratic functions, we had mentioned in each one of these videos what is easy to identify using that form. Or we had identified what you can identify. And again, just in case I don't want to go back on my own word, but just in case I didn't mention what's easy to identify in those other videos, I believe I did. But if I didn't, let's put it that way. If I didn't, then we're gonna go ahead on and get it right here. So again, guys, on that Khan Academy assignment, the questions may sort of be a little framed similar to what you see here. So they may ask something like, what is the most efficient form to use when identifying the y-intercept? Or you know, hold on real quick. Let's see, where was I? Aha, there we go. Or it may look like something like this. What's the most efficient form, or which form most quickly reveals the, you know? And so, you know, they'll ask that there. And so, can you tell me what is the most efficient form to use when identifying the y-intercept? Okay, that's Jeopardy. Alright, you should be able to tell me that the standard form, guys, is the most efficient form for identifying your y-intercept. And you should be able to tell me exactly which part or which parts of the standard form. Wow, okay, yeah. Which parts of the standard form actually identifies that y-intercept? Because again, we talked about that. So the standard form for quadratic is, of course, your ew. Oh, that is so ugly. We're gonna try this again. Oh, that's so much better. Oh, so much better. Alright. Standard form for quadratic is, of course, y equals, or f of x equals ax squared plus bx plus c. Alright. And so we should know that which part here identifies your y-intercept. And again, you can identify that y-intercept because the y-intercept will be the c value. Whatever the value of c is, that will be what your y-intercept is. And we talked about this in one of our previous lessons, in one of the other videos on the standard form for quadratic functions. But yeah, so again, that value, that c value, is going to be your y-intercept. Y-intercept is the c value. It's the value of c. Alrighty. And so again, I'm not getting ready to put an example here because you guys should know how to identify what the value of c is. You should know how to identify what the value of a is and b is at this point in time. If not, go back and look at one of the previous videos. Go back and look at that video on standard form for quadratic functions, and you'll see if you don't remember. Alright, so next, guys, they may also ask you something in the form like this. What is the most efficient form to use when identifying the maximum or the maximum value? Alright? Or of course, guys, it doesn't have to say maximum. It could say minimum, or it might say minimum value. Again, now the question, it probably on Khan Academy it wouldn't ask you for both maximum and maximum value. You know, it wouldn't ask you which one, but I mean, I'm just saying, or it could be minimum or minimum value. Guys, remember there's a difference between what the maximum is and what a maximum value is. Just like there's a difference between what a minimum is and what a minimum value is, okay? Alright, remember that a maximum or minimum for a quadratic function is always going to be the vertex. That highest point in the case of a maximum, again, is going to be the vertex. And so The maximum is going to be the vertex, and of course, if they asked about minimum, that would be the vertex, and it would be the lowest point on the parabola, right? The maximum value is remember the y value of the vertex, or is that function value at the maximum. But again, in layman's terms, it's the y value of the vertex. So again, the maximum value or minimum value, they would be talking about the y value of the vertex. So, I wonder what form could be the most efficient for identifying a maximum or a maximum value. If the maximum is a vertex, I wonder. Well, folks, I don't know. I give up. Alright, so remember, guys, that again the vertex form would be that form that is the most efficient to use when you're identifying the maximum or a maximum value, or again if you're identifying the minimum or a minimum value. And again, they may actually come right out and say when identifying the vertex or the y value. They not say the y value of the vertex. They would say maximum value or minimum value. I'm just letting you know on Khan Academy. Anyway, all right. So remember that the vertex form is this form here. Y equals a times x minus h squared plus k. Alright, and so guys, remember that in this form you identify the vertex by using two of those components. Ooh, something is in my eye. That's alright. By identifying two of those components, you use the h and the k, right? We use the opposite sign. This one. Use the opposite sign of whatever you see in the equation to identify h, and you use the exact same number, the exact value here for whatever you see in the equation for k. And so remember again, folks, that remember again, guys, that the vertex is going to be written in the form of or the maximum, in other words, the maximum or the minimum, whatever you want to call it, vertex, maximum, minimum, is going to be written in that form of HK as an ordered pair. Alright, and so again, guys, if you know what the vertex is by looking at this form, then you should have no trouble with identifying the maximum value, again the y value of the vertex, or the minimum value, the y value of the vertex. Again, folks, if you have identified what the vertex is in this form, you should have no problems, because I'm telling you up front, and I've already told you in a separate video. I've told you in the video for the vertex form, again, that a maximum value or minimum value is, well, if I didn't tell you in that video, I told you in one of those videos. Standard form or the vertex form, I know I told you. Alright, so the last thing is that we're going to do is which form is the most efficient form for identifying zeros or roots. Alright, so remember, guys, that we've heard these terms before, zeros and roots. Remember, guys, that zeros and roots are the real solutions in this particular case for quadratic functions. They're your real solutions for quadratic functions. Yeah, that is not how you spell solutions. I don't know what I was trying to spell there. Alright, so, and guys, remember that that when we say real solutions for quadratic functions, we are talking about none other than x-intercepts. Yes, we are. Oh, yes, we are. Oh, yes, we are. We's talking about x-intercepts. Now, if only there was a form for quadratic functions where it was easy to identify x-intercepts. Better put on my thinking cap. Well, the form that we're doing right now, the form that this video is about. This video is about that form where it's easy to identify x-intercepts. What's the name of that form again? What was the name of, Lord have mercy, where it's easy to identify x-intercepts? What's the name? X-intercept. I remember now. Oh no, it's not intercept form, isn't it? It sure is. You know what? Boy, it's intercept form. Alright, so again folks, that's what this video's on, the intercept form, which is that form y equals or f of x equals, where you got your a, and you got your x minus p and your x minus q. And remember that to identify the x-intercepts, which is what they're really asking for when they ask you about identifying zeros or identifying roots. They're talking about x-intercepts. You're going to need to look at the p and the q value. And again, folks, remember that you're going to use the opposite sign. Use the opposite sign for both of them. Use the opposite sign for the for what you see in the equation. That you're going to use the opposite sign for both. Okay. Alright folks, that's all. That's it. That's everything. That's all I got to say. That's it right there. That's it. It's over. It's done. Finito. It's over. Sayonara. Bye. Adios. Ciao. I do hope that this video has been helpful to you. Again, folks, this video was highlighting the intercept form of quadratic functions, and again, there was a certain part of it that again I just wanted to use to explain from my students who are enrolled in my classes exactly how I want you to show that work. But again, I do hope that this video was helpful to you. That's all. That's it.